Okay, after this break, we are coming to the next talk, Pygeoapi. Just van den Broecke and Francesco Bartoli will talk about it, about the OGC standards which are covered by it. So welcome, Just and Francesco.
Yes, thanks. Very much, Martin, and thanks for you and the organizing team for organizing this in well, let's say COVID times. I hope everyone can hear me clear. Yes, so Francesco Bartoli and I will present this Pygeoapi and OGC API to geospatial data. And actually, we have good news for you. If you have been working with OGC, OGC is the Open Geospatial Consortium that defines many of the web standards for geospatial data. You probably heard of WMS, WFS. You probably struggled with it. The good news is there are new APIs, RESTful, and Pygeoapi is an implementation of that. That's the main message. And we'll go from here. Francesco will be switching the slides. We share his screen. So next, please. So basically, yeah, this will be the contents, but we'll go from here. So next. So yeah, there's been a let's say an evolution of APIs. If you're a little bit older like me, you probably have heard of XML RPC Core, but then there came a whole, the SOAP began basically with WSDL, UDDI, service-oriented architect. It's about the 90s. At that time, the OGC also defined the WMS, the Web Mapping Service. Next, please. And in the 2000s, there was the advance of Web 2.0, JavaScript Ajax, Slippy maps, if you think of OpenStreetMap. And then OGC also brought out other standards, the Web Feature Service, Coverage Service, Processing Service, CSW for metadata. Probably you worked with it. I can't see hands up, but may probably also struggled with it. Okay, next, please. Because there are some realities of OGC Web Service. So basically, there are requests using HTTP GET, POST, and SOAP, and responses. Now, there you go already. XML, GML, geographic markup language can be very complex for both, but also error handling. Basically, HTTP was seen as a sort of pipeline, and the OGC standard tend to do their own custom error handling. There were it's still in use, of course, exhaustive specifications. Next. So this is an example of how a single feature could look like, or a feature collection with a single feature member. Next. So there was some complex architecture still needed to basically unlock. I won't go too much into this picture. Next, please. So the real web world at the meantime was busy with defining new kinds of APIs. Next. And yeah, under what is called REST, representational state transfer, you probably all have heard about it. It's about HTTP verbs, HTTP codes, using URIs to identify resources, using content negotiation, a lot of good things basically, and easier to use if we just compare it, of course, to the existing OGC standards. Next. And as far as content, there's data can be defined in JSON instead of XML, which is supposed to be easy to write and understand, and it's quite popular among web developers. So although that's still now emerging. Next. And it also culminated in something called OpenAPI, which evolved from Swagger, and that's basically a specification on how to describe a RESTful API. So there's a sort of single specification language. So it's a language to define a language, basically. So it defines endpoints, request parameters, response, and it's programming language agnostic. So you have Python, JavaScript implementation, and formerly it was called Swagger. I think now it's about OpenAPI version 3.0. Next. So this is an example of some definition in OpenAPI language. Next. And Swagger is also, let's say, the OpenAPI client tooling, and it has what is very interesting, automated documentation and testing. So with this Swagger documents, you can already try out APIs. We will see that probably later in the demo. Next. So OGC luckily listened to all this activity on the let's say the real web. So next. So there has been, they started with a study already a couple of years ago, which is called, together with W3C, the Worldwide Web Consortium. It's called W3C Spatial Data on the Web Best Practices. And it's a very readable document. By the way, we'll share the link to this presentation soon after this presentation. It's web. So let's see what was the previous slide about. So the OGC did also proceed with this document, the spatial data on the web, as it is called, and yeah, basically it came to, let's say, design patterns being webby, which means, let's say, web friendly for humans, for search engines, because that was also one of the disadvantages. Like a WFS, it's not searchable. You cannot find features via Google or one of the other search engines, DuckDuckGo. So it must be developer friendly. There's also sort of requirements, lightweight specification, and especially removing HTTP to use as a tunnel. But really use the HTTP verbs and response codes, content negotiation, and have some kind of modular specification development. Next, please. So timeline here. Next, please. So things moved quite fast. So there are already OGC standards for basically the equivalence of what we know. One of the first was the OGC API features, which was first dubbed WFS version 3. But they now have their own naming, and you can see all of the existing standards are now sort of redefined. So it's a complete, yeah, you could also say paradigm shift from the previous standard. So if you're now entering the, let's say, the OGC world, you have a much easier time than let's say 10 years ago. Next. Yeah, the other aspect is that the OGC now also has sort of more open processes. The standards are even defined on GitHub, and the issue tracking is used. Standards are released as HTML, where there used to be Word documents, I think even behind the login wall. You can talk with the specification developers on Gitter. Next. So now we come to Pygeoapi. So we have this goodness, we have new standards, and very early on, Pygeoapi was started by Tom Karalidis, and he has started many other projects. And well, on Valentine's Day, so it was created with love, and it's now an OSGeo community project. Next. And what is Pygeoapi? It's basically a geospatial data API framework, and we're already, I mean, I say we because Francesco and I are also developers within the Pygeoapi project. And we have an international team, so we're developers from Canada, the Netherlands, Greece, Italy, New Zealand. And if you look, because we also built on existing mainly Python libraries, you could say, if we count all the dependencies, we have like 21,000 upstream contributors. So we're also standing on the shoulders of giants, you could say. Let's say GDAL OGR, for instance. Next, because I still have 5 minutes. So technical overview. Yeah, basically it's about data publishing, but we leave the data as it is. So in many, like if you have a WFS, you had to first bring your data to a PostGIS database, and then no, we basically fit to the data. And I mean Pygeoapi, so we can leverage a powerful ecosystem of Python packages. Next. So technically, it's a maybe it's better we move on because we have a nice picture about the architecture. So this is the architecture. It's basically 3 layers. So we have the API, and I should say the API. With Pygeoapi, we tend to implement all the upcoming OGC APIs. We started out with features, and that's quite stable. Oh yeah, it says. So the 3 layers. So we have a web layer, and that is currently mainly based on Flask, but it could be any WSGI-based web framework in Python. And then we have a core module, and then we have specific what we call data providers, and these are defined as plugins. So we see an OGR plugin. I will talk about it later. We can have an Elasticsearch plugin, CSW, whatever, and all is defined via a configuration YAML file. So you can construct your own, let's say, stack with Pygeoapi instance. Next, please. So the data provider. So I mentioned Elasticsearch, CSW, Spatialite, GeoJSON, and it has a star because next. This is one of the things I worked on, and Francesco as well. We initially had already a what we call a GDAL OGR provider, and GDAL OGR is, let's say, the Swiss Army knife of data access, geospatial data access. And using the OGR Python bindings, we can unleash like 100 vector formats. And we had paging, reprojection. And one of the nice things is we could unlock existing WFSs. So basically, Pygeoapi would be a proxy to existing WFSs. So that could also be a migration path if you still have a WFS and you want to migrate to OGC API features. So next. And there's also, we're now implementing coverage data providers. So that's for WCS type of thing. And then the next would be the tile data providers. And Francesco will talk about that a little bit later. Next, please. And yeah, we support schema.org. That has to do also with being searchable. And for instance, now you could find features via Google search or DuckDuckGo, whatever. And that's, yeah, it's all about metadata in the documents when you have an HTML representation. And next, we'll see that later. And we also define link data via JSON LD, so you can have, well, link data. Next. And we have a demo, and that's what Francesco will show later on. Next. And in the demo, you would also see the OpenAPI. So the OpenAPI specification is part of the Pygeoapi implementation. And well, okay, and this is an HTML representation. So now we can do next. We see that in the demo. And this is also for the coverages. And next we have the tiles. And I still have 1 minute. And processes. Oh yeah, that's for WPS, web processing service, a replacement basically. Next, please. Spatial. Now the list is endless because this was all recently added. Stack, the spatial temporal asset catalog. Next. Next. Oh, I should say there's a thunderstorm. Oh no, the in Italy, I wanted to say where Francesco is living. So, but luckily, thunder didn't strike yet, or lightning. Yeah, this is a little bit about deployment. We'll not tell too much about it. Next, it's usually the next, please. But the most important and the easiest way to run Pygeoapi is using Docker. You could be up and running like in 5 minutes. We have Docker images on Docker Hub. Next. And yeah, this is basically it to get it running, and you get a default configuration, and from there you can of course extend it with your own data sources. Next. Docker options. Well, we'll skip this. Scaling, of course, you can scale out once you have Docker. Next. Probably some production instances. We can skip a little bit quicker because I'm already. So there's already some production instances, and now I'll hand over to Francesco. He will talk a bit about the roadmap, and already this slide is a bit old. So I hand over to you, Francesco.
Thanks. Well, thanks, Justin, for this excellent overview about Pygeoapi. Now, I want just to add some briefly some information about our roadmap. So, as you mentioned, the OGC API tiles is the last minute feature that landed mastered just yesterday. Very nice. And I'll talk a bit more about that in a couple of minutes, demonstrating with a quick demo its capabilities. Then there is maps, very close to tiles in some corners cases, but also crucial for the overall OGC APIs landscape. We know everybody loves maps, and we need to display geospatial data on maps. So we have to come up with this implementation very soon, because we want to push forward the digital transformation of spatial data infrastructures. Well, then also, as you in the list that you has showed, there is records. It is another essential piece as a replacement of the CSW specification. Usually, as you told, OGC encourage developers to participate in co-sprint, and I would expect they are going to call a new dedicated sprint for the records specification very soon. And in terms of timeline, we expect these both of them implemented before the release, the stable release of Pygeoapi 1.0. The process API has an early implementation, but recently its OpenAPI specification changed a bit, and now it is in the public comment phase from the OGC. So even here we expect to do some more alignment in the next months. And then, yeah, very one of the most powerful feature of Pygeoapi, it's the data providers and the plugin architecture that you mentioned before. Data providers are a continuous evolution. We have plenty of them already in the code, and we usually add more as soon as there is demand for them. I want just to say that the process is slightly easy and doable, even for developers who don't know the core of Pygeoapi. So it's very straightforward. And in terms of next upcoming data provider, I would expect, I'm quite sure that one of the next to come would be PostGIS as a backend provider for serving dynamic Mapbox vector tiles. Well, then things to mention is that we participate in the Google Summer of Code with 2 proposals, one for the transactional aspect and the other for advanced filters capabilities in the OGC API feature with the CQL extension. We have now both of them as a PR from the student that participated with Pygeoapi, and this is expected to be a work to be merged very soon by the end of the year. Then, well, I will skip content negotiation with just to say that we will come up probably with more formats like GeoPackage and GML. And OSGeo Live, it's one of our option for the delivery of Pygeoapi. So now I will skip the support. There are few providers with their business, and then to conclude, there is some links. But now I want to just give you and demonstrate Pygeoapi. So this is a local instance of Pygeoapi. As just mentioned, one essential piece is its configuration. I have put under a GitHub gist this configuration. It's very simple, and we have in this configuration 2 let's say resources. One is called ops, observation, and the other is called lakes. Lakes, it's relevant for the tiles specification. In fact, we have 2 providers in the lakes stuff. One of type feature, which implements the OGC API features, and it is based on a GeoJSON file. And the other one, it's for tiles. For tiles, the Mapbox vector tiles as a protobuf file has been pre-generated and have been pushed to a Minio backend server, which is running at localhost port 9000. So let's jump in the, this is the Pygeoapi landing page. Here you have the different kind of specification. We have processes, we have stack, and we have collection. Under collection, we have probably one thing to mention is the OpenAPI document. There is a JSON version and the Swagger page here. And so we can retrieve for the lakes still the tiles and points. So going deeply in the collection, we have the HTML representation, and then we have the link to the lakes collection. And here we have several future links. Obviously, there is under view, there is specifically the link to the features and points, but I want to stick a little bit with tiles, which is the latest features landed the master. So I can follow this link, and we have this nice HTML representation backed by vector tiles, where I can obviously also in the map call I can get feature info pop up, and there is it can have different tile matrix identifier, and upper there is the JSON representation also, which is a JSON payload with the links to the specific for specific for having specific the link for serving tiles, and also the metadata of the tile representations. If I go back, there is also here the links for navigating through the tiles metadata page, where there is I can have a page with all the elements from the tile JSON version 3.0 specification, which comes from the original layer from Minio about this tile layer. Yeah, if I have some more time, I can, for instance, go also to as just demonstrate before. This is the representation, the HTML representation of features. There is a Sleepy Web map where I can obviously here the returned content is a GeoJSON, and obviously I can also query and ask for the pop-up from the map. And if I follow the JSON representation, I got the feature collection of the lakes collection. And yeah, I think that's all. As said here, there are some links. There is the home page, the website of Pygeoapi, where the documentation lives. There is a demo where you can find where me, Just, and Tom deployed several different use cases for demoing. There is one tool that is backed by COVID-19 data, which are republished on the fly from the John John Hopkins University, and also from as a CSV from GitHub repo from the public Italian administration. There is the Docker, our Docker app for Pygeoapi, where you can download the images, and the link for the mail and the Gitter chat, where you can discuss feature and ask for new things and demand for